Have you ever thought about being a rock star?
I have!
Well, you don't need music to be a rock star. All you have to do is study the processes of the rock cycle, like weathering and erosion.
The rock cycle?
No thanks, man.
Cycle.
OMG! We just learned the coolest thing in geography today.
Okay. You know what? If we're gonna keep talking about this rock cycle thing, I'm gonna leave this conversation.
No, but we have his super chill geography teacher. He has a chalet and everything. But wait, that's not the point.
Did you know there are 3 different types of rock?
Of course. There's like a black rock, a red rock, I don't know.
Oh my god.
What?
Here, let's start from the bottom.
Started from the bottom, now we're here. Started.
Not that bottom.
Okay, here guys, let's just watch a video.
Today we're going to learn about the rock cycle and the key processes of the rock cycle. So, there are 3 different types of rock: igneous rocks, sedimentary rocks, and metamorphic rocks. And the 3 major key processes of the rock cycle are melting and cooling, also known as crystallization, weathering and erosion, and finally, heat and pressure, also known as metamorphism. These processes can turn one type of rock into another type of rock. So let's begin with igneous rocks. These rocks are formed when lava or magma cools and hardens. The word igneous comes from the word fire. You know, like when you ignite a candle, the liquid candle wax drips and hardens. And depending where the molten rock cools down, it can either form an intrusive or extrusive igneous rock. All rocks were once melted because of the Earth's hot temperature. The melted material is called magma. Inside the Earth's core, there are a lot of pressure. If the surface can't handle the pressure, it breaks and magma comes out. Then, when a volcano erupts, magma becomes lava if it reaches the Earth's surface. Some magma cools before it can reach the surface, which creates intrusive igneous rock, which has a lot of crystals. Wait. So you're telling me like that rocks transforms like Transformers? Nah, you have to be kidding me. Those rocks that are just laying down there on the ground all day? Oh, hell no.
Pay attention!
However, if lava cools down outside on the Earth's surface, it cools down rapidly, forming an extrusive igneous rock, which has less crystals, since the rate at which an igneous rock cools down affects how many crystals and bubbles the igneous rock will have. So the key process of how igneous rocks are formed is melting and cooling, the melting and cooling of rock. Now, let's move on to sedimentary rock. These rocks are formed by the compaction and cementing of layer sediments, which have been broken down by one of the key processes of the rock cycle, weathering and erosion. Weathering is the breaking down or dissolving of rocks and minerals on Earth's surface into smaller pieces, which are called sediments.
Lorena?
Okay, so when solid rocks become sediments, aren't they like taken away by wind, water, and ice?
Okay, how did you know that?
Homie, I listen in geography class.
You do?
I mean, of course I do, when I'm not sleeping.
Can we just finish the video? I have history notes to do, and I only have 50 pages.
Okay. Water, ice, acids, salt, plants, animals, and changes in the temperature are all agents of weathering. When you leave soap with running water, the soap changes its form. It is weathered and eroded by water. Once the rock has been broken down, A process called erosion transports the bits of rock and minerals away. Once transported to a specific location, old sediments are compacted by new sediments. The remaining gaps are filled with different materials during a process called cementation and become sedimentary rocks. With weathering, erosion, transportation, compaction, and cementation, rocks become sedimentary rocks. Sedimentary rocks are arranged in layers called strata. Now let's move on to the final type of rock, metamorphic rock. These rocks are formed when igneous or sedimentary rocks are put under a lot of heat and pressure. The key process through which rocks are changed into metamorphic rocks, also known as metamorphism. When a rock is exposed to extreme heat and pressure within the earth but does not melt, the rock becomes metamorphosed. Metamorphism may change the mineral composition and the texture of the rock. For that reason, a metamorphic rock may have a new mineral composition and/or texture. Let's recap. So the three main types of rock are igneous, metamorphic, and sedimentary. The three processes that change one rock to another are melting and cooling, weathering and erosion, and heat and pressure. Any rock can transform into another rock by passing through one or more of these processes. If magma cools underneath the earth, it becomes intrusive igneous rock. If it cools above the earth after a volcanic eruption, it is called an extrusive igneous rock. Rocks are weathered and eroded. These sediments go through processes like transportation, compaction, and cementation to create sedimentary rock. Both igneous and sedimentary rock becomes metamorphic under a lot of heat and pressure.
Let's look at it from a bigger picture. The rock cycle is driven by two sources of energy to change the formation of the rock: the solar energy given from above and the Earth's thermal energy given below. This is the Earth's surface. The solar energy is responsible for our atmosphere and hydrosphere. The atmosphere makes it possible for Earth to have wind by mixing cold and hot air, and water through precipitation. With wind and water, weathering and erosion can occur. Extrusive igneous rock are broken down into raw sediments by weathering and erosion. These sediments are deposited and transported from land to sea. Lithification, another name for processes of compaction and cementation, must occur before sediments turn into sedimentary rock. With heat and pressure, sedimentary rock will form metamorphic rock. Both sedimentary and metamorphic rock can cause mountains to build up. Intrusive igneous rock can also become metamorphic with heat and pressure, or it can become extrusive igneous rock if the magma is extruded. From below, the decaying of radioactive materials and the intense heat gives Earth its asthenosphere, where convection current occurs. With convection current, magma can flow and travel to the Earth's surface. This allows magma to turn into lava and form extrusive igneous rock once it is cooled and solidified.
That, my friends, is the rock cycle. Damn, that video was litty and very educational. What if you try an experiment to see how it works?
What works?
Weathering.
Well, there's an experiment on Ellen. Why don't we watch that?
Sure.
Here she is now, Ellen DeGeneres.
Hello and welcome back. Today we have a very special guest from Loretto Abbey. A couple of students who filmed a parody about their teachers that went viral. Let's watch it. Hey guys, let's talk about the video you filmed here. So, Mr. Cappadocia?
Caps. You can call me Caps.
Alright, Caps. So, did you have any idea your students were filming you, even the tiniest bit?
Well, my students are a bit special, so it wasn't anything out of the ordinary.
And from my understanding, these girls have an experiment to show us?
Yeah, we'll be doing an experiment on weathering.
Perfect. Let's watch it.
To test weathering at home, you need different types of rocks, a cup of water, and 3 containers with the different labels of the classifications of water. First thing you do is sort the rocks by their classification. The sedimentary rock, the igneous rock, and the metamorphic rocks. The next thing you do is pour 1.5 cups of water in each container. After you finish filling up all the containers, then you can put the lid on it and put the rocks in the freezer. It is recommended that you leave the rocks in the freezer for 1 day, then record the changes after it defrosts on the 2nd day. Leave the rocks in the freezer for 1 day and then record the results. Your day 1 result should look like this. All the water has completely frozen and the rocks are now embedded in the ice.
On the counter, in room temperature, or in a separate area for a day, and observe the changes after the water has melted to the different rocks.
After a week of freezing and thawing, we can see that the metamorphic rock had little to no erosion. The sedimentary rock had also very little erosion, and that the igneous rock had a lot of erosion. This is because that the igneous rock was the least strongest compact out of all 3 of them, with sedimentary being next, then the 2 metamorphic rocks.
You might be wondering how freezing and thawing can break a rock apart. This process is called frost action, a type of physical weathering. During the day, the temperature is higher. The water from precipitation or condensation will fill up the small cracks between the rocks. At night, the temperature will drop, causing the water to freeze. When water freezes and forms ice, the crack will expand, allowing the increased pressure to crack and shatter the rocks.
We should totally try that.
Oh my god, that video totally rocked. Get it? Rocked?
We got it. It's just not funny.
When you try your best but you don't succeed. When you feel so tired that you can't sleep.
Several days later.
Oh my god, Vanessa, do you know what type of rock gets broken down the quickest?
Yeah, sedimentary rocks, the ones that are arranged in layers, because the rock particles, they're like spread apart, so that means they're weaker and easier to break apart. And metamorphic rocks, they're harder because they went through like a lot of heat and pressure. Remember the rock cycle? We learned that last year. But it depends on the composition and the degree of cementation of sedimentary rocks, because some sedimentaries, I remember him saying it was harder to break apart and others are easier.
Got it. Okay. So basically sedimentary because they're weaker and particles further apart, and then metamorphic, they are the hardest because of all the process they go through. Okay, got it. So any examples?
Yeah, sandstone is a type of sedimentary rock, and it's soft, so it's easily weathered. And limestone, it has calcium carbonate, so it really depends on the area. So if it's dry, it would last longer, but if it's a moist area, then it would be weathered easier.
Okay, Gushy fam. Thanks for the info. Hopefully I don't fail. matter because it depends on cementation and boom, 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 yeah.
Ask for the
Example.
Lorena?
Vanessa.
It's easier to get broken down. And metamorphic rock are they're
Alright, stop. I don't even know. I gotta see.
What type of rock gets broken down first? Oh my god!
there's an experiment
Oh my god!
for their parts and then
I can't hear you!
they're
Number 8. I mean, see number 9. Cut.
well it says on my note.
I don't know my lines.
No, don't record me anymore. I can't. And here she is, Ellen DeGeneres. And yeah.
Examples. There's sandstone and there no you keep going.
That was really interesting. We should try that.